Hey guys, welcome back with the continuation of the same lecture. We were dealing with the past papers of some mixture type of chapters. You may say it is containing some mixture type of concepts. We are dealing with some of the concepts of atomic structure, bonding, and periodic table as well. Okay, so we have solved these three questions in our previous video. Right now, I am on the next question. It is question number 22 here at the top. You can see this thing. A student has five reagents. Okay, number one is dilute hydrochloric acid. So what's the formula of dilute hydrochloric acid? Let me make it a little bit thinner. Okay, so what's the formula of HCl? It is hydrochloric acid HCl and sulfuric acid H2SO4, whereas nitric acid is HNO3, calcium carbonate is CaCO3, copper carbonate is CuCO3. They are then asking that how many soluble salts can be prepared from these five reagents. Okay, five reagents means these five chemicals. Okay, reagent is the chemical actually. Okay, so for this question a student should know what is a salt solubility. So I have taught you in the chapter of acid, bases and salts that what is the salt solubility. I am giving you a review related to salt solubility. All nitrates are soluble without any exception. All salts of group number 1 are soluble without any exception. All salts of ammonium family are soluble without any exception. All chlorides are soluble except lead, silver and mercury. All sulfates are soluble except lead, barium and calcium. So this is the salt solubility. All acids are soluble without any exception. Acid is not under the category of salts, but we should know the solubility of the acids as well. If we are talking about the base solubility, all bases are considered as insoluble except for the metal oxides and metal hydroxides of group number 1, metal oxide and metal hydroxide of strontium and barium. Remaining all oxides and hydroxides are considered as insoluble. So this is a brief review of the solubility. If we are looking into it, we can say this thing that it is this combination is going to produce calcium chloride. How? When calcium carbonate is going to react with HCl, it is producing calcium chloride, which is a soluble salt. This combination is going to produce calcium nitrate as well. Why? Because calcium carbonate is going to react with nitric acid, making calcium nitrate. Calcium carbonate can react with H2SO4 as well, and it is going to make calcium sulfate, which is an insoluble salt. So this is not one of the soluble list, one of the salt of the soluble list. Okay, then copper carbonate is going to react with HCl, H2SO4 and HNO3 to make copper nitrate, copper sulfate and copper chloride. So all of these are the soluble salts. Okay. Here I have written very clearly that calcium sulfate will be prepared from this combination as well, but it is considered as insoluble salt. So if we are looking onto the salt solubility, the answer is 5. We have just written all the salts which will be prepared according to the solubility, and they are 5 in number. Okay. The table shows the number of electrons in one atom of each of the element W, X, Y and Z. So we have W, X, Y and Z. Before moving towards question, one should do the working here. Number of electrons in one atom. W has 9. 9 mean what is the electronic configuration? 2 and 7. 2 in the first shell and 7 in the last shell. X means 15 means 2, 8, 5. It is part of the group number 5. How it is? Because 5 electrons are there in the outermost shell. It is telling you that it is a part of group number 5. Let's look at Y. Y is 19, 2, 8, 8, 1. So it is a part of group number 1. Which element is this 19? Potassium. We will have the periodic table for the MCQ paper. Okay. Then it is Z. Okay. So now what is Z? It is 35. Okay. So we are having this electronic configuration thingy from atomic number 1 till atomic number 20. So we are unaware how to write down the electronic configuration of 35. We will teach you the electronic configuration till the element number 36. I mean to say atomic number 36, but in AS level. But right now in O levels and in IGCSE we have taught you the electronic configuration from atomic number 1 till atomic number 20. Okay, so this is 35. Okay, we are going to open the periodic table. This 35 is bromine. So 35 bromine, it is a part of group number 7. We know this information that 2 electrons are in the first shell, so dot 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 dot, and 7 will be there in the outermost shell. Why? Because bromine is a part of group number 7. So we have just written 7. Okay. So this is X is phosphorus, and how we know X is phosphorus? Because 15 is the atomic number of phosphorus, and this is a part of group number 5, and this is a non-metal. Okay, now we are moving towards the question. Which statement is correct? W and X are in the same group. Let's see. W is having 7 electrons in its outermost shell, whereas Z is having 7 electrons in its outermost shell. Yes, this can be the same thing because all the elements of the same group have same number of electrons in their outermost shell. So we can say this thing that W and Z are in the same group. What about X is a metal? No, X is not a metal. We have just seen this thing that it is 15285. 5 means atomic number is part of group number 5, so it means that it is group number 5, hence it is not a metal. So B is a wrong option. What about C? X and Y will form the compound X3Y. Let's see. X is a part of group number 5. From this electronic configuration we now know this thing that X is a part of group number 5. Y is a part of group number 1. How it is? Because Y is 192881 and it is group number 1, so we are just writing group number 5 minus 3, group number 1 plus 1, cross multiply these numbers as I have taught you how to develop the formula of the ionic compound. It is 1:3. It means that XY3. They are saying X3Y, but the formula which we are calculating from this all working is XY3. So it means that C is the wrong option. What about D? Y is a non-metal. Okay, let's see. Y2881. Oh, 1. It means that it is part of group number 1. So it means that it is a pure metal. And which metal it is? It is potassium. So it means that D is the wrong option as well. So which is the right option for this question? It is A. Okay. So one should know this thing that what is the right option, rather one should know this thing as well that what are the wrong options and how they are wrong options. Okay, so this is the actual way of solving the MCQ paper. Now I am on question number 24. Some properties of the elements in group number, you may say 7, and the reasons of their properties are shown. So property is there and the reason is there. Which row shows the property and the reason for this property? Okay, all the elements exist as diatomic molecules. Okay, each element has 7 electrons in their outermost shell and can share a pair of electrons. Yes, this is the explanation about group number 7. If we are looking into fluorine, it is F2, chlorine Cl2, bromine Br2. They all have 7 electrons in their outermost shell and they are sharing one electron. So overall there one pair of electron in the sharing region. Okay, done. Let's have a look on B. The elements are classified as metals. Okay, when solid, the elements are shiny. The elements are classified as metals. When solid, the elements are shiny. We can say this thing as well. The elements are classified as metals when solid, and the elements are shiny. Yes, we can say this thing. Okay, so we must say this thing. This is the correct thing. This cross should not be here. Okay, let's have a look on the next point. Iodine displaces bromine. No, iodine cannot displace bromine. Okay, so that's why this is the wrong option here, because iodine is lesser in the reactivity as compared to bromine. When I was teaching you the chapter of periodic table, I have taught you that in group number 7 reactivity decreases down the group, and the higher reactivity halogen has the ability to displace the low reactivity halogen. So bromine is more reactive as compared to iodine. So bromine can displace iodine. Iodine cannot displace bromine. That's why this C property is wrong. What about D? The boiling point increases as the group descendants. Okay, as the group is descendant, it becomes harder to break the covalent bond between the atoms. Guys, it is requiring a little bit more explanation. Look at here right now. This is fluorine, okay, and this is chlorine, okay. Look at the bond of the chlorine, and this is bromine, okay, and this is this. And what about the iodine? It is like this, okay. Why we are increasing the bond length? Basically, depending upon the atomic number, fluorine has an atomic number of 9, whereas iodine has an atomic number of 53. So one iodine is making a bond with another iodine. One iodine atom has a 53 electron, whereas the other iodine atom has 53 electrons. So their bond length is increasing. Bond length is basically the distance between the two nuclei of the atoms sharing the electrons with each other. Okay, so we can see this thing that higher is the atomic number, longer is the bond length, and shorter will be the bond energy. Lesser will be the heat energy required to break that bond. So in this way we can say this thing that D property is right, but D reason is wrong. Okay, so covalent bond is not getting difficult to break, rather it is becoming easier to break. Okay, so all the, and now look at the option number A as well. I should consider my selected option as well. Let's see. The elements exist as diatomic molecules. Okay, we are saying F2, Cl2, Br2, etc. each atom has 7 electrons in their outermost shell and can share a pair of electrons. There is the problem with this pair. I was just thinking that there is a pair in one molecule. If one atom from F2 is sharing one electron, whereas the other F is sharing one electron, so there will be total one pair of electron in the central part, the sharing region. But here they are saying each atom has 7 electrons. Yes, each of the atom has 7 electrons in the outermost shell and can share a pair of electrons. No, one atom cannot share a pair of electrons. Let's write down this. For example, we are saying this is F. I am writing it here a little bit here. Probably it is, yes, it is here 9, 2 and 7, and this is again here 9, 2 and 7. So each of the fluorine is going to share one electron with each other. So overall this is like this. Okay, so we can say this thing that there will be total one pair of electron, one partner from one electron from one partner, whereas the other electron from the other partner. We are not saying that each of the fluorine is sharing one pair of electron, but this explanation is saying that each of the pair of the electron is shared by one partner. No, in this case, when they have 7 electrons in their outermost shell, they are going to share one electron with each other. So according to these all, this is wrong here, this is wrong here. So what is the right option for this question? It is B option, which is right. No doubt, when metals are solid and they are metals, they are solid and they have shiny surface. Okay, now I am on question number 4 on the next page. I'm going to tell it to you this thing again. I have told it in the previous video as well, that I have just selected some of the common questions, some of the previously asked question, and I am just solving some of the questions as a sample, so that you people may have a trick and may have an idea how to solve some of the questions related to these concepts. Okay, which statement about the isotopes of bromine is correct? Okay, so let me write the isotopes of bromine. It is 35 and it is 81, and it is 35 and it is 79. Okay, these are the two isotopes of bromine. Do we need to keep them in our mind? No. They are atoms with the same number of electrons and different number of protons. No. In case of isotopes, and electrons and protons should be similar, whereas the neutron number should be different. Basically, the proton is the basic thing which should be similar. Okay. They are the atoms with the same number of neutrons. No, atoms cannot have the same number of neutrons in case of isotopes. Okay, they are the atoms with the same number of protons and same chemical properties. Yes, when we have the same number of protons, it means the same number of electrons, and electrons are responsible for the chemical properties, so they have the same chemical properties. In case of isotopes, as neutron number is undergoing a change, it means that physical properties are undergoing a change. Guys, I'm giving you a reminder. Physical properties were boiling point, melting point, and the density, etc. They are the atoms with the same number of protons and the same physical properties. No, in case of isotopes, the physical properties are different. So C is the right option. Okay. So which diagram shows a section of ionic lattice of sodium chloride? In case of sodium chloride, I have taught you that this is the cubical structure, and one sodium is the positively charged. It's going to make a bond with two sides, and rather three sides, and all of them are negatively charged. So you can see this thing, that none of the positive is attached with the positive, and then none of the negative is attached with the negative. Rather, positive is attached with the negative, and the negative is attached with the positive. Okay, so this is the positive wrong. Okay, and here in this case, positive and negative are there, but they have given the positive to Cl and negative to Na. So this is wrong, and here the negative and negatives are wrong and positives are wrong as well, and they are making one sheet at the top for the Na1 minus. This is completely entirely wrong. So this is this only, and this is the same structure which we have drawn for calcium oxide as well. Calcium was Ca2 plus and O was 2 minus. Okay. So here it is, when dilute hydrochloric acid is added to lead nitrate, white precipitates of the lead chloride are formed. Guys, I am going to write this equation here in detail. You can see this thing, that HCl is there, and along with this it is PbNO3 twice. I am going to convert it into its ions. It is balanced chemical equation with 2. It will be PbCl2, and we can say that along with this 2HNO3 as well. So these are the aqueous ones, so we are going to convert them into their components, and the remaining will be as it is. So it will be 2H plus and 2Cl1 minus, and it will be Pb2 plus along with 2NO3 1 minus, and this is PbCl2, and this is going to convert itself into 2H plus 2NO3 1 minus, and now we are going to cancel the spectator ions. We can see this thing that these are the spectator ions and the remaining are the ions which are going to combine with each other to make the ionic equation. So this is the ionic equation which we have already practiced in the ionic equation lectures as well. Okay, so this is the C option. You can see aqueous, and the solid is here. Okay, now I am on the next page. Oh, this is a theory now. Okay, let's have a look on some of the theory questions. Now they are saying the question is about metals. Okay, so this type of the questions can be asked from those students who are going to appear for the small monthly test or small tests which are related to periodic table, etc. Okay, so chromium is a transitional block element, sodium is an element chromium. Okay guys, chromium is with the symbol Cr. Okay, it has an atomic number of 22. Chromium is a transitional block element. Sodium is an element in group number 1 of the periodic table. State two physical properties of chromium that are different to those of the sodium. Guys, I have taught you what are the typical properties of the transitional block elements. They are entirely different from rest of the elements of the periodic table. So transitional block elements have the high melting point, high boiling point, high density. They can make colored compounds. They can show variable oxidation state. They are acting as a catalyst in different type of the chemical reaction. So here they are asking about the physical properties. What we can write: high melting point, high density, high melting point, not high boiling point. Whenever you are talking about the physical property of a solid, you should talk about its melting point, not about its boiling point. And if you are talking about the gas or a liquid, then you can talk about the boiling point. Okay, chromium makes colored compound, whereas sodium makes white color compound, or you may say compounds of chromium are making colored solutions, for example, whereas sodium is going to make the colorless solution. For example, you can write this thing as well, that chromium is used as a catalyst in different reactions, sodium is not used as a catalyst of different reactions, etc. Okay, deduce the number of protons and neutrons in chromium atom. Guys, this is the chromium atom written in the paper. Might be this is different from that of the periodic table, might be they are going to give you some elements isotope. Okay, so you have to give the answer according to your paper. So number of protons, how many number of protons are there? 24. Might be key is not given, but what is the trick which I have told you, that out of the two numbers, the number which is smaller in value, small figure, will be considered as the atomic number or the proton number. So these are the proton number. And what about the neutron number? It is 53 minus 24, which is equal to 29. Okay, so now we can see in question number C, chromium oxide, okay, Cr2O3 reacts with carbon, okay, and chlorine to produce chromium 3 chloride, and that is formula CrCl3 and carbon monoxide. Done. Guys, can you look at there right now? That question has 2 marks. Okay, whereas they are not saying you to write down the balanced chemical equation. Here they are asking about symbolic equation. So sometimes in some of the paper, examiner is asking you to write down the word equation. Over there is no need to write the formula, but once one examiner is mentioning very clearly that you have to write the symbolic equation, then you cannot write the word equation in that case. So what is the formula? Cr2O3 is reacting with 3C is reacting with 3Cl2, making 2CrCl3 plus 3CO. Guys, this balancing of the chemical equation, I have selected this paper deliberately so that you people may have an idea that you need to balance the chemical equation on your own. Guys, here they have given you all the material. I mean to say this is reacting, this is the formula, this will be the product, etc. So this is the only thing which you should know, that how to balance this equation. So it is not a bigger task, it is just requiring a small effort related to balancing practice. Okay, so complete the diagram here according to the electronic configuration, and this is the sodium ion. We can see this thing, that sodium ion has this. Sodium is having atomic number of 11, and what is the electronic configuration? It is 281. Now they are saying this thing, sodium ion, and it is 2 electronic shells, and it is +1 here. Why it is +1? 1 electron is lost in this case. So from where that 1 electron is going? From the inner shell? No, it is going from the outer shell. So we have just removed this electron. Okay, now we are on the next question. they have this table right now. They are asking give the letters of all the particles which are atoms. We can see this thing which are atoms, so they must have the same number of electron and proton. We can see this thing that in this case electron and proton are similar, in this case electron and proton are similar, whereas in this case electron and proton are similar. So we have written all, so they have specifically asked for all the particles. Okay, ion with the charge of -2, it means that it must have gained 2 electrons. So this is D and E. You can see this thing that in D there are 18 electron, whereas proton are 2 lesser, so it means that it has gained 2 electron, whereas in E it is also a negatively charged. So they are, I guess I should not write down the E answer, because in E the number is -1, not -2, so it is not that. What about the ions? Ions, they are mentioning ions, so which is that then? D, and we have to look into that, and that is, I guess this is D only, because there is no one with the -2. E is gaining 1 electron, so E is -1, not -2, because in E 1 electron is greater than proton. Okay, so D will be the only answer for number 2. Okay, then they are saying positive ions, that are the cations. This is C. How it is? Because number of electrons are reduced in this case, so 13 was the proton number and 3 electrons are reduced in C, so it is making a positively charged ion. Then they are asking state the atomic number of A. So it is 5, and how it is? Because the atomic number is the number of the protons basically, which we have written here. Okay, then they are asking determine the number of nucleons in D. It is 16 plus 17 is equal to 33. What is the nucleon number? Nucleon is the number of the protons and number of the neutrons sum up. Neutrons and protons are called as the nucleons, which are the particles existing inside the nucleus. So this is 33 here. Protons and neutrons are making nucleons. That is this. State the electronic configuration of D here. They are asking. Okay, so what is the answer for this? Electronic configuration 16 means D is 16. You can see the proton number is just the source for the electronic configuration. So 16 286. So it means that it is a part of group number 6, and it is a part of period number 3. So total number of electronic shells are telling you about the period number, and the last shell electrons are telling you the group number. State the group number of F. You can see F is 15. 15 is 285, so it is part of group number 5. Okay, whereas it is part of period number 3. What about the period of B? It is 10. It is 10. Look at B. It is 10. 10 means 2, 8. 8 means how many total electronic shells are there? 2. So it is part of period number 2. Okay. Now I am on the next question, and that is related to cobalt and copper. Cobalt and copper are the transition block elements. Copper has 2 naturally occurring isotopes, copper 63, copper 65. Cobalt has 1 naturally occurring isotope, that is cobalt 59. And this is the table here. They are asking that we have to write the protons and electrons and neutrons. Protons are given in the periodic table 27, 29 for copper. Neutrons we have just subtracted 59 minus 27 and 65. I should write here 65. There is a problem here. I should write 65 here, and then this will be changed as well. So it is 65. Why 65? Because this is 65, and 15 minus 9 is 6, and 5 minus 2 is 3, so it will become 36. Okay, so then they are asking about the electrons. So here in copper 2 electrons are lesser because it is 2 plus charge, you can see, and in cobalt the same number of electrons because no electron is gained or lost. Okay, then there is another question. It is a question related to the isotopic abundance. Okay, so you have the isotopic abundance, relative abundance of the 2 naturally occurring isotopes of copper. You can see one is 63, which is 70%, one is 65, which is 30%, and we have to calculate the relative atomic mass till 1 decimal place. So it is the formula which we have done in our previous working related to isotopes. So it is the abundance multiplied by its mass, or you may say percentage, by the atomic mass plus percentage percentage by the atomic mass. So we are just multiplying the percentage with that of the respective atomic mass divided by 100. So we have just done this whole working. So one of the isotope is 70% and its atomic mass is 63, whereas the other is 30% and its atomic mass is 65, divided by total, which is 100. We have done this whole working. The answer is 63.6. Okay. So one physical property of the transition block elements such as copper and cobalt is that they are hard. Okay. So it means that we can say about the transition block elements that one of the physical properties is that they have the high melting point and they have the high density. We can say them as well that the metals of the transition block elements are hard. Can you recall that thing that I have taught you that in group number 1 the metals are quite very soft, can be cut with the knife? So this cannot be implementable in the transitional block elements. Okay. So state two physical properties of the copper and cobalt which are significantly different from lithium. Cobalt and copper are making colored compounds and they have the high melting point and high density, whereas the lithium is not making colored compounds and it is very softer and it has a low melting point as well. Then they are asking both copper and cobalt can form colored compounds. Some of these compounds contain water of crystallization. Define the term of water of crystallization. Water molecules which are attached with the salt crystal during its formation are called as the water of crystallization. I have given you few examples. If you can recall this thing, that it was CuSO4.5H2O. It was there is another example, FeSO4.7H2O. For example, there can be Na2CO3 dot 10H2O. So these are the examples of the water of crystallization, and water of crystallization is always written with the dot. Okay. So then they are asking that state the color and the formula of the hydrated cobalt chloride. Cobalt chloride is CoCl2.6H2O and it is pink or red with water. Whereas if we are going to heat it and water will be removed and the color will be changed from pink or red to blue. So cobalt chloride with water is pink or red and without water it is blue. State the color change which is seen when the few drops of the water are added to copper sulfate. Copper sulfate without water it is white, whereas with water it is blue in color. So you need to memorize the colors of the cobalt chloride and copper sulfate with water and without water. These two colors are part of your syllabus. Okay. And remember this thing, color change means before and after. Okay. So for example, if water is there as water of crystallization, if we are going to heat that compound, obviously water will be lost and compound will lose those water of crystallization molecules. Okay. So they are asking state how this change can be reversed. It means that how we can remove that water of crystallization by heating as water will be removed. Okay. So try to give the complete answer to the examiner. Okay. Then they are asking that there is a table over there. Okay. And they are asking which is the noble gas. It is B. Why? Because it has 8 electrons in its outermost shell. Then they are asking that an atom of group number 6. Okay. So 6 is F. How it is? Because it has 6 electrons in its outermost shell. So outermost shell electrons are telling that this is the group number. So F is the part of group number 6. Atomic number 14 is D. How it is? 2, 8, 4. We are going to add this whole thing. 2 and 8 is 10 and 4 is 14. So this is D. They are atoms of the same group A and E. How it is? Because in A that is 5 electrons in its outermost shell, whereas in E 5 electrons in the outermost shell. So both of them are part of the same group. Then it is a halogen atom. It is G. How? Because 7 electrons are in the outermost shell. All the halogens have 7 electrons in their outermost shell. Then an atom of an element which is good conductor of electricity. This is C. How it is? Because it is 2 electrons in the outermost shell, which is telling that it is a metal of group number 2. All the metals can conduct electricity. So this is C option answer. Then a stable ion of group number 5 element. It is B. How it is? Because group number 5 elements are going to gain electrons. For example, going to gain 3 electrons. For example, if we are talking about 2 and 5, for example, this is nitrogen, and now it is going to, you may say it is going to gain 3 electrons, and after that it is 2 and 8. So you can say about this is B, which is going to make which is going to be a stable ion formed from the elements of group number 5. Okay. Then they are asking about the last part, an atom that forms an ion with a -2 charge. It is F. How it is? Because it has 6 electrons in its outermost shell, it is going to convert it into 8 by gaining 2 electrons. So that's why it is -2. So these are the things which are relating the periodic table and atomic structure chapter and bonding chapter together. They are involved, they are interlinked with each other, they are involved into each other, you may say. Okay. Then there is another question, and there are 2 more questions which I have selected for you to make a practice for that. Okay guys, look at this question. This question is about the group number 5 of the periodic table. These are the information, these are the elements of the group number 5. This is density, and these are the melting points. Then they are saying predict the density of the antimony. Antimony is Sn. Guys, I'm writing the symbols. Nitrogen is N, phosphorus is P, arsenic is As, and antimony is, this is antimony, and that is called that is Sb, and then this is bismuth, and this is Bi. Okay, then antimony is there, and then for example I have written the answer 7.2. Okay, I have written the answer 7.2. Okay, how it is 7.2? Guys, can you look at there right now? It is increasing from 2.34 to 5.73. So if we are adding like 2, for example 2 into it, it is between 9.8 and 5.3. So we have just taken the central number, so it means that it can be any number. We have to estimate, we have to predict. This is not the fixed number. Many of the students can write 7.1, might be someone is writing 7, might be someone is writing 7.3. All will be considered as the correct value. Okay, so whenever we have to estimate, whenever we have to predict, we don't write the exact number. Then they are asking, suggest why it is difficult to predict the melting point of arsenic. Guys, can you look at there right now that it is increasing, and it is then increasing. Okay, and it is then decreasing. You can see it is a lesser value. So as there is not a specific trend, not a specific regular pattern, that's why the answer is irregular trend. Then there are two diagrams here in this B part. Oh, it is P3 minus and Na plus 1. It means that positively charged and negatively charged ions are holding each other tightly through electrostatic forces of attraction. So the word of electrostatic force of attraction will be used in case of a metal where we are using the positively charged nuclei and the negatively charged electronic C, or for the ionic compounds. Then it is SO. It is a covalently bonded structure because phosphorus and hydrogen both are non-metals. Then they are asking, explain in terms of the structure and bonding why compound R has a high melting point and compound S has a low melting point. We can see R and S. So R is basically an ionic compound. R is a combination of positively charged and the negatively charged ions holding each other tightly through strong electrostatic force of attractions, and they are demanding high temperature to break these force of attractions. That's why R has a high melting point. When we are talking about the S, we can say this thing that it is a covalently bonded structure. Molecules of pH3, that is called as phosphine. What is pH3? It is called as phosphine, and here I am writing phosphine. Yes, you should know this is phosphine, the formula and the name is this. Okay, and then I am saying you that it is a molecular structure. Covalently bonded structures are molecular structures. Okay, so we are saying that molecules of pH3 are holding each other through weaker intermolecular forces of attraction. So molecules are formed through covalent bonding, whereas molecules are holding each other. One molecule and another molecule are holding each other through weaker intermolecular forces. That's why we can say this thing that they have the low melting points. Now I am on the next page. Explain why a compound R conducts electricity when molten. You can see this thing that compound R is stronger force of attraction, stronger electrostatic force of attraction. So when we are going to heat it, the force of attractions will be broken and ions are free in the molten state. They are asking us to draw the structure of S dot and cross diagram. It is PH3. You can see I have written here P is going to share 3 electrons with 3 hydrogen. I am going to write the electronic configuration. It is 15 and 2, 8, 5. So it means that 5 electrons are there in the outermost shell. These 2 electrons are as lone electrons. They are talking about all the outer shells. So we are going to draw all the outer shell electrons. Out of the 5, 3 are in the sharing region with 3 hydrogens, whereas 2 electrons are as lone electrons. Then they are saying you to calculate the percentage by mass of phosphorus in this compound. Which compound is this? P4O10. Many of the students who have not studied the concept of moles with me might be they are unaware of this fact that how to calculate this percentage, but I will teach you that chapter as well, inshallah, in detail. Right now we are just calculating the percentage of phosphorus in this compound. So this is the percentage of phosphorus is equal to total phosphorus divided by total compound into 100. How many times phosphorus is there? 4. And what is the mass of one phosphorus? It is 31. So it is 31 times 4 divided by total compound. So 31 times 4 plus 16 times 10. What is 16? It is the atomic mass of one oxygen times 10 because it is for 10 times. So it is total phosphorus divided by total compound multiplied by 100. Okay, and this is why the percentage is mentioned over there. Okay, so percentage is calculated like this. I am on the last question for this session, and that is the question is about the halogens. Halogens are the compounds of the group number 7. Draw a dot and cross diagram for chlorine molecule. This is the way to draw the dot and cross diagram for chlorine. You can see this thing from this practice. It is very clear that many of the questions are related to the atomic structure. So what is the use of chlorine? Might be this chlorine uses not very much in clarity. Might be it is not very much clear in your mind, but it is one of the common use. You might have seen this chlorine in the swimming pools. And what is the use there? It is to kill germs. So we can see this thing to kill water germs. Okay, for the purification of water, you may say. So aqueous chlorine reacts with potassium bromide. Chlorine is reacting with potassium bromide, and as a result bromine and potassium chloride is formed. Why this reaction is happening? Because chlorine is more reactive as compared to bromine. Then we can say this thing, that what is the color of bromine? It is red brown. Explain using so these are the colors which you people need to keep in your mind. So chlorine is greenish yellow, or fluorine is white, etc, etc. So explain using ideas about the reactivity of the halogens. Why aqueous bromine does not react with aqueous potassium chloride? Because chlorine is more reactive as compared to bromine, so chlorine will not let bromine to replace it, whereas chlorine can displace bromine from its compounds. Okay, so bromine is a liquid at room temperature. Bromine is a liquid. You already know, I have taught you that fluorine and chlorine are the gases, bromine is the liquid, whereas iodine and astatine are the solids. Okay, then we can see this thing that they are asking about the arrangement and the separation in case of the bromine. Arrangement, as it is a liquid, so it loose arrangement is there, and in case of the separation, not attached with each other, whereas they are not random as well. So we can say this thing that they are not attached with each other as in solids. Okay, so then there is another question. Chlorofluorocarbons are the atmospheric pollutants, okay, which deplete the ozone layer. Explain the importance of the ozone layer. Describe one problem caused by the depletion of the ozone layer. Okay, guys, atmosphere is basically a layer of 15 kilometer around earth. Atmosphere is an air cover of 15 kilometer around earth. Atmosphere is divided into 4 components. The number 1 is called as the troposphere, the next one is mesosphere, the next one is stratosphere, and the last one is called as the ionosphere. So this stratosphere is made up of ozone, and ozone has formula O3. This is the shield which is stopping the ultraviolet radiations of sun coming to earth. As a result of that, it is stopping many of the dangerous effects, many of the very much toxic effects of these ultraviolet radiations, we may say. So when these chlorofluorocarbons will become part of our environment, they are going to react with this ozone. They are converting this O3 of ozone into O2 oxygen. As a result of that, a hole is created over there from where the ultraviolet radiations of sun are entering, and they can cause skin cancer. So they are asking specifically skin cancer, I have told you, because examiner is asking the particular reason and particular effect, the consequence. What is the importance of this? Ozone layer stops ultraviolet radiations of sun. And what is the problem? Ultraviolet radiations can cause skin cancer. Okay, so guys, I have solved many of the questions with you, some of the theory questions and some of the MCQ questions as well. Hope this will be helpful to many of the students who are preparing for periodic table, and who are preparing for equation development, and who are thinking what are the displacement reactions, etc, etc. All the best to all of you. See you in the next class.